Okay, after having seen properties of modulus, properties of argument, properties of conjugates, and the De Moivre's theorem, let us now see properties of cis theta. These are very important properties. I want every one of you to be attentive while I am telling you these properties. The first property is cis theta. I have told everybody cis theta is nothing but cos theta plus I sin theta. Second property, cis theta 1, cis theta 2, cis theta 3, they are multiplied up to, let us say, cis theta n. So when we multiply cis theta 1, cis theta 2, cis theta t, cis theta 3, so on to cis theta n, what we get is cis theta 1 plus theta 2 plus theta 3 plus theta n. This is what we get. This is a very important property. Mostly in problem solving, this will be used. Property number 3, cis theta 1 divided by cis theta 2 is equal to cis theta 1 minus theta 2. And mind it, we can add any multiples of 2 pi or any multiples of or we can subtract any multiple of 2 pi. The cis theta will remain same. This can also be written as cis 2k pi plus theta 1 minus theta 2, where k belongs to integer. Okay, property number 4. I mean, I have already stated, but let me explicitly write it. Cis theta is equal to cis 2k pi plus theta. K belongs to integer. It could be negative or positive. All right. Number 5. Number 5. This property says the conjugate of cis theta is equal to cis minus theta. So we can also write here. We can write here 1 by cis theta is equal to cis minus theta. Okay, this property is same as this property. So cis theta 2, when it goes to the numerator, it becomes cis of minus theta 2. Seventh, mod of cis theta. Okay, let me write here. Mod of cis theta is equal to 1. Yes, right, because that is precisely the definition of cis theta. R cis theta, the magnitude of this is r. So it is so this cis theta is multiplied by 1. That is why the magnitude of cis theta is equal to 1. And the same line I can write magnitude of r. Yeah, magnitude of r cis theta is equal to r. Okay. And what about argument of cis theta is equal to theta. Because this is polar form, the argument is directly written in form in cis theta in the form of direct angle. And let us solve some examples now. The first example is, let z be a complex number with imaginary of z is equal to 10, and it satisfies 2z minus n divided by 2z plus 1 is equal to 2i minus 1 for some natural number n. Then these four options are given. We have to find the correct option. First is n is equal to 20 and real object is minus 10. Second is n is equal to 40 and real object is 10. Third is n is 40 and real object is minus 10. And fourth is n is equal to 20 and real object is 10. We have to find the correct answer. This question came in JEE 2019. It is a simple question, but I'll tell you which concept you have to apply first, and then I will solve it partially. You solve it fully, and then let me know what is the answer. The concept here, that I'm going to use is if A by B is equal to C by D, where of course B and D are not equal to 0, then this concept I'm going to use in this question. Then A plus B divided by B will be equal to C plus D divided by D. This is called componendo. This is called componendo. A minus B, I'll write this first, this second. A minus B divided by B will be equal to C minus D divided by D. This is called dividendo. So if A by B is equal to C by D, then this is true, and that is called computendo. And if A by B is equal to C by D, then this is also true, and that is called dividendo. And if we combine both of them, I will get A plus B divided by A minus B is equal to C plus D divided by C minus D. That is computendo and dividendo. Both. So we are going to apply this concept. Then second concept we apply here is equality of complex number. Equality of complex numbers. So these two concepts we will apply. Let us see now. So given what is given, imaginary of z is 10. Let us assume z is equal to x plus 10i, right? Because imaginary of z is given as 10, so I've directly put 10 in place of imaginary part of complex number. X is a variable which we will find out based on the given conditions. Okay. So what else is given? It's given 2z minus n divided by 2z plus n. Sorry, it should be plus n. Sorry. 2z minus n divided by 2z plus n is equal to 2i minus 1. So 2z minus n divided by 2z plus n is equal to 2i minus 1. I can write 1 in the denominator so that I can apply componendo and dividendo simultaneously. So componendo says if a by b is equal to c by d, then componendo and dividendo says a plus b divided by a minus b will be equal to c plus d divided by c minus d. So we will do it here. This is a, in the denominator. This is b. Here in the numerator a, and in the denominator 1. So we will say a plus b. A plus b, it will be 4z divided by, if I say a minus d, I will get minus 2n. Here I will say a plus b, c plus d, sorry, this will be equal to 2i divided by 2i minus 2. I can cross multiply now. So this will be equal to minus 4 i n is equal to 8 zi minus 8z. Take 4 common out. This becomes minus I n equal to 2zi minus 2z. Let us put z is equal to x plus 10i. This one x plus 10i. So minus I n is equal to 2x plus 10i I minus 2x plus 10i. Okay, let us now expand these brackets. Minus I n is equal to 2ix 2ix plus 20i square minus 2x minus 20i. So minus I n is equal to 2ix 20i square. I square is minus 1, so it becomes minus 20 minus 2x minus 20i. Let us take everything on one side. So I will get 20 plus 20 plus 2x plus 20i minus 2ix minus in equal to 0. Okay, I have taken everything on left hand side. Now let us segregate, put it in form x plus iy. So this becomes 2x plus 20 plus I 20 minus 2x 20 minus 2x minus n equal to 0. Now there is a complex number on left hand side, a plus ib or x plus iy, and there is a complex number on the right hand side, which is 0 plus 0i. And if I equate, the equality of complex number tells me that if two complex numbers are equal, then their real part will be equal and their imaginary parts will be equal simultaneously. So this I can write 0 plus 0i. So I will get 2x plus 20 is equal to 0, and I will get 20 minus 2x minus n equal to 0. So x part, the real part of complex number, is equal to 0. The imaginary part of complex number is equal to 0. This is the equality. So here I will get x is equal to minus 10. And if I put x is equal to minus 10 here, I will get 20 plus 20 equal to n is equal to 40. So my answer is n is equal to 40, sorry, n is equal to 40, and real part of z is equal to minus 10. To see, n is equal to 40, this one, C. So this is the correct answer, right? Yeah, C is the correct answer. It is a simple question. Two concepts we have to remember: componendo and dividendo, and then equality of complex numbers. Let us take another example, and this is a value of theta for which 2 plus 3i sine theta divided by 1 minus 2i sine theta is purely imaginary. Then what is the value of theta? Pi by 3, pi by 6, sine inverse root 3 by 4, and sine inverse 1 by root 3. So this we will solve, and let me tell you which concept we are going to use here. Which concept? कौन से concept use करेंगे इधर? If z is purely imaginary, then z plus z bar will be equal to 0. This we will use. Second property we will use. Second property is Z1 by Z2 the whole bar is equal to Z1 bar by Z2 bar. And third property, Z1 plus or minus Z2 the whole bar is equal to Z1 bar plus minus Z2 bar. These three properties we will use. So it is given that 2 plus 3i sin theta, 2 plus 3i sin theta divided by 1 minus 2i sin theta is purely imaginary. It is given that this complex number is purely imaginary. So if z is purely imaginary, then the complex number z plus the conjugate of that complex number will be equal to 0. So plus 2 plus 3i sin theta divided by 1 minus 2i sin theta, the whole bar will be equal to 0. Okay. Now just concentrate here what I'm going to do. 2 plus 3i sin theta divided by 1 minus 2i sin theta plus, now this bar will go to numerator and denominator subsequently here, and then it will distribute to plus and minus. So I will directly write what is the conjugate of this. 2 minus 3i sin theta divided by 1 plus 2i sin theta is equal to 0. Now let us cross multiply. 1, so 2 plus 3i sin theta plus 2i sin theta, 4i sin theta. This will be equal to 6 plus 6i square sin square theta. Okay, this multiplication plus 2 minus 3i sin theta, 2i sin theta minus 4i sin theta, and minus minus plus 2 into 3 is 6i square sin square theta equal to 0. Okay, so 3i sin theta, 3i sin theta gets cancelled. 4i sin theta will also get cancelled. Now I am left with 2 minus I square is minus 1. 2 minus 6 sin square theta plus 2. This also I square is minus 1 minus 6 sin square theta equal to 0. You get 6 12 sin square theta, right? So if I take on the right hand side, it will become 12 sin square theta is equal to 4. Sin square theta is equal to 1 by 3. So sin theta is equal to 1 by root 3. Theta will become sin inverse 1 by root 3. I think the answer is D. Okay. Another example. Here the concept that we are going to use is the properties of cis theta, number 1, and number 2, De Moivre's theorem. De Moivre's theorem. Okay, so so let us take this 1 plus I divided by 1 minus I to the power n. I have already told how to convert Cartesian form to polar form. 1 plus I will become root 2 cis pi by 4 divided by, this will become root 2 cis minus pi by 4 the whole power n. This will give me cis pi by 4 divided by cis minus pi by 4 to the power n. Now another concept here is cis theta 1 divided by cis theta 2 is equal to cis theta 1 minus theta 2. So here this will become cis pi by 4 plus pi by 4. This is nothing but cis pi by 2 to the power n, and cis pi by 2 is nothing but I to the power n. So if this has to be equal to 1, if this has to be equal to 1, then smallest possible value of n will be equal to 4, right? I to the power 4 is equal to 1. It can be I to the power 8, I to the power 16, any multiple of 4, but the smallest positive integer for which this is equal to n will be n is equal to 4. So none of these. So the answer is none of these. Now, before we take few more complex problems, let us just recap and see simple convergence from Cartesian system of complex number to polar form of complex number. So let us see this one. The first one is 1 plus I root 3. So this is the Cartesian form of a complex number, and what we can write this equal to, this will be 2 cis pi by 3, right? You can just recap your previous classes and check whether this is correct or not. 2, I will write root 3 plus I, and that is nothing but 2 cis pi by 6, right? Then I can write 1 plus I, that is nothing but is equal to root 2 cis pi by 4. Similarly, 1 minus I is equal to root 2 cis minus pi by 4. I want every one of you to make sure that you understand what I'm writing, and make sure that you are also able to convert each of these Cartesian form into the polar form. Okay. Number 5, what is 1? 1 is nothing but cis 0. What is minus 1? Minus 1 is nothing but cis pi. I have done this, and I have extensively explained this in previous classes, how to convert polar to rectangular coordinate system, and how to convert from Cartesian to polar coordinate system. 7 I will be nothing but equal to cis pi by 2. 8 minus I will be nothing but equal to cis of minus pi by 2. Okay, a few more. 1 minus I root 3 will be equal to 2 cis minus pi by 3, because this will lie in fourth quadrant. Then root 3 minus I will be equal to 2 cis minus pi by 6, and then I think 1 minus I have already written. So these are the few convergence from Cartesian form to polar form. And as I have said in De Moivre's theorem, that I can add any number of or any multiple of 2 pi to each of the complex number. So this can also be written as 2 cis pi by 3 plus 2k pi. This can also be written as 2 cis pi by 6 plus 2k pi. Where k is an integer, it can be a positive integer, it can be a negative integer. In short, I want to say I can add or subtract any multiple of 2 pi to a given complex numbers argument, and the complex number will not change. It depends on our requirement whether we want to add multiples of 2 pi or we want to subtract multiples of 2 pi to solve our problem. We will see in subsequent classes, or maybe a couple of minutes from now, what is the use of all this. Similarly, here also we can add root 2 cis pi by 4 plus 2k pi, and to all of them we can do that. Like here we can write 2 cis minus pi by 6 plus 2k pi, and just to just for the sake of completion, I am writing here k belongs to integer. So k can be a positive integer. It has to be an integer. It cannot be a fraction. It has to be integer 1, 2, 3, 4, 0, minus 1, minus 2, minus 3, minus 4. So it can be a positive integer. It can be a negative integer. Positive integer means you are adding multiples of 2 pi, and negative integers means you are adding you are subtracting multiples of 2 pi. And doesn't matter you add 100 multiples, 200 multiples, 5 multiples, the complex number remains same, but only thing you have to make sure that you add that multiples of 2 pi to the argument of complex number, not anywhere else. Now after seeing this, let me solve few simple examples before we go to little more complicated and the questions that came to JEE. But before that, few basics. So let us say example 1 plus I root 3 to the power 12. How shall we solve it? That is where precisely I'm going to tell you the use of De Moivre's theorem. And I have told already what is the polar representation of 1 plus I root 3. I will not repeat it again. That is 2 cis pi by 3, and that will become to the power 12. I will take 12 separately, 2 to the power separately to 2 and separately to pi by 3, and this is exactly where I'm going to apply the concept of De Moivre's theorem. De Moivre's theorem says that cis theta to the power n is cis n theta if n is an integer, and so 12 will come inside, right? So 2 to the power 12 cis 12 pi by 3, cis 12 pi by 3, and now this will become 2 to the power 12 cis 4 pi, cis 4 pi, right? Now we have seen just before that we can add or subtract any multiples of 2 pi to any complex numbers argument. So what I will do, I will write here 2 to the power 12 cis, I will subtract 4 pi to this, and that will become 2 to the power 12 cis 0, and cis 0 is nothing but 1. So the answer is 2 to the power 12. So very simple. Only thing you have to remember the concept of De Moivre's theorem, and where exactly you want to add, where exactly you want to subtract the multiples of 2 pi to the argument of a complex number. We'll see more questions, more examples, and then it will be very clear to you. Next example. Next example is 1 plus I to the power, let us say, I want to solve 1 plus I to the power, let us take 76. Okay, so this will become root 2 cis pi by 4 to the power 76. Okay, so this will be 2 to the power 38, right? Cis 76 pi by 4, 76 pi by 4. That will be 2 to the power 38 cis 19 pi, no? 19 pi, and that's precisely where I'm going to use again the concept of adding multiples of 2 pi or subtracting multiples of 2 pi. This will be equal to 2 to the power 38 cis 19 pi minus, I can subtract any multiples of 2 pi, so I'm subtracting here 18 pi. I'm subtracting here 9 multiples of 2 pi, and that is precisely 18 pi, and that will become 2 to the power 38 cis pi, and cis pi is precisely minus 1. We have seen it before. This will become minus 2 to the power 38. That is the answer, right? Another example, let us take. Which one I can take? Root 3 plus I to the power 38. This one I can take. Okay. So this is nothing but 2 cis. What is root 3 plus I? 2 cis pi by 6 to the power 38. This will become 2 to the power 38 cis 38 pi by 6, right? De Moivre's theorem. 38 pi by 6. That is nothing but 2 to the power 38 cis 19 pi by 3. And this I will write 2 to the power 38 cis, I can write this pi by 3 plus 6 pi. So this is again 3 multiples of 2 pi. I can remove it. Remove. I have told it before that I can add or subtract any multiple of 2 pi. So this will become 2 to the power 38 cis pi by 3, and I can write here 2 to the power 37 into 2 cis pi by 3, and 2 cis pi by 3 we have already seen. What is 2 cis pi by 3? 1 plus I root 3. This is equal to 2 to the power 37 1 plus I root 3. So this is the answer. Next example, let us take. Next example, which one we can take? Yeah, let us take a bigger example now. Let us take a big example now. Slightly complicated, not complicated, but slightly complex as compared to these previous examples. I am going to solve now. 1 plus I to the power 72, 1 plus I root 3 to the power 36, root 3 plus I to the power 72 divided by 1 minus I to the power 36 root 3 minus I to the power 18. This I am going to solve, and believe me, this might look little more complex, little more lengthy, but this is, I might take few more steps for you to understand it clearly, but this is precisely 2 to 3 step solution. And if you have understood the previous examples, then this is going to be very easy. So 1 plus I is root 2 cis pi by 4 to the power 72. 1 plus I root 3 is nothing but 2 cis pi by 3 to the power 36. Root 3 plus I is nothing but 2 cis pi by 6 to the power 72 divided by 1 minus I is root 2 cis minus pi by 4 to the power 36, and root 3 minus I is 2 cis minus pi by 6 to the power 18. Okay, now De Moivre's theorem, cis theta to the power n is cis n theta to each of these terms. To each of these terms, we are going to apply De Moivre's theorem, and then we will apply um, another property of cis theta to further take denominator to numerators. Let us first apply De Moivre's theorem. This will become 2 to the power 36 cis 72 pi by 4. This will become 2 to the power 36 cis 36 pi by 3. This will become 2 to the power 72 cis 72 pi by 6 divided by 2 to the power 18 cis minus 36 pi by 4, 2 to the power 18 cis minus 18 pi by 6. Okay, now let us further solve it. 2 to the power 36 cis, this 17 by 4 is 18, right? Yeah, 18 pi. 2 to the power 36, 36 pi by 3 is 12 pi cis 12 pi. 2 to the power 72 cis, how much is this? 18, right? 72 by 6, 12 pi divided by 2 to the power 18 cis minus 9 pi and 2 to the power 18 cis minus 3 pi. Okay, this is simple. Equal to, now 18 pi cis 18 pi, I can subtract or add any multiples of 2 pi. So 18 pi minus 18 pi, this will become cis 0. Similarly, this will become cis 0. Similarly, this will become cis 0, and cis 0 is nothing but 1. So in the numerator, I am going to get 2 to the power 36 into 2 to the power 36 into 2 to the power 72 divided by 2 to the power 18, and in minus 9 pi I can add any multiples of 2 pi, so I'll add 10 pi. So I will be getting here cis pi, and similarly here in minus 3 pi I will add 4 pi, which will give me cis pi again into 2 to the power 18 cis pi. And cis pi, if you recall, cis pi is nothing but, where is cis pi? Cis pi is this angle at 1 unit from here. So cis pi is minus 1. So I will get, so this is minus 1, this is minus 1, and minus 1 is plus 1. So the ultimate answer is 2 to the power 36 into 2 to the power 36 into 2 to the power 72 divided by 2 to the power 18 by 2 to the power 18. So these two will get cancelled, and I am remaining with 2 to the power 36 plus 72, which is nothing but 2 to the power 108. That is the answer of this question, which you think it might look little complex, but it is just the application of De Moivre's theorem, application of adding multiples of 2 pi, subtracting multiples of 2 pi, and the answer is nothing but very easy. And this came in JEE advanced exams, wherein you might have got 4 marks for this kind of simple question. Now this example says, if a is greater than 0 and z is equal to 1 plus I squared divided by a minus I, this complex number z has a magnitude of root 2 by 5. Then what is the conjugate of z? And these are the options. This question came in JEE 2019 means. Now let us solve. So it is given that the magnitude of solution. And okay, before that, let me tell you what is the concept we are going to use here. The main concept we are going to use here, z1 by z2 bar is equal to z1 bar divided by z2 bar. This is the concept. Of course, other concept we will also use, but this is the main concept that we are going to use here. So it is given that the magnitude of 1 plus I square divided by a minus I is equal to root 2 by 5. This is given, and we have to find out what is the value of z bar. So from this, what do you think? From this, what we are going to find out? From this, we are going to find out the value of a, and then we will put the value of a here and find the value of z bar. So this says, now here we will say mod of z1 by mod of z2 is mod of z1 by mod of z2. So this will become 1 plus I square mod divided by mod a minus I divide is equal to root 2 by 5. So 1 plus I is nothing but root 2 cis pi by 4 square mod divided by mod of a minus I is under root a square plus 1 is equal to root 2 by 5. This says, now we will apply here De Moivre's theorem. 2 will come inside, so this will become 2 cis. 2 will come inside, so it will become cis pi by 2, right? Mod divided by root of a square plus 1 is equal to root 2 by 5. And now what is cis pi by 2? Cis pi by 2 is nothing but, cis pi by 2 is I, right? So 2I mod divided by root a square plus 1 is equal to root 2 by 5. And what is the mod of 2I? That is where we will apply mod of z1 z2 is equal to mod of z1 into mod of z2. Okay, so this will become mod of 2 into mod of I divided by root a square plus 1 is equal to root 2 by 5. And what is mod of I? Mod of I is 1, mod of 2 is 2. So this will become 2 divided by root a square plus 1 is equal to root 2 by 5. Now we will square both sides. 4 divided by a square plus 1 is equal to 2 by 5. This will become 2, 2 will cancel here. So this will become a square plus 1 is equal to 10. This means a square is equal to 9. This means a is equal to plus minus 3. Now z is equal to 1 plus I square divided by a minus I. And now since we have found value of a, you can actually put the value of a here and find the value of what is z, and then so finally what is the value of z bar. I'll just tell you how to find z bar. Z bar is found basically by replacing I with minus I everywhere. So Z bar is equal to 1 minus I square divided by A plus I. Now you rationalize it. This will become 1 minus I square A minus I divided by A plus A minus I. Rationalize means I have multiplied A minus I, the conjugate of A plus I, into the denominator and into the numerator. By doing this, what I will get denominator as a real number, and that will precisely give me only I in the numerator. Denominator will not have any I. And if you solve this further, you will get the answer. The answer you should get is A. Just this is your homework. From this point, you take it further and find what is the final answer. Okay. This is another question. It says that let Z be a complex number such that mod Z plus Z is equal to 3 plus I, then mod Z is equal to. We have to find the value of magnitude of Z. So the concept here we are going to use is solution. The concept here we are going to use is equality of complex number. Equality of complex numbers. Now given is mod Z plus Z is equal to 3 plus I. Let us say Z is equal to x plus iy. So what I have here is, let me rewrite it first. Mod Z is equal to minus Z plus 3 plus I. I have taken Z on the right hand side, so that left hand side is purely real because mod Z is a magnitude. Magnitude is a real number. So mod Z, that is mod x plus iy, sorry, mod Z is equal to minus x minus iy plus 3 plus I, which is equal to minus x plus 3 plus I 1 minus y is equal to mod Z. Now concentrate here and see that left hand side is mod Z, which is purely real number. Mod Z means magnitude of Z. Magnitude of Z means its length of that point from the origin by which the Z is represented by. So mod Z is a real number on the left hand side. On the right hand side, I should also have a real number because that is what is the equality. So if left hand side is real, the right hand side should also be real. And for the right hand side to be real, you have to have the complex part, the imaginary part of this complex number equal to 0. That means this implies 1 minus y should be 0. Should be 0, which is equal, that means y is equal to 1. So we have got y is equal to 1. Now let us put it here. Mod z is equal to, now when y is equal to 1, this becomes 0. This becomes 0 means mod z is equal to minus x plus 3. Let us put x plus iy, y is 1, is equal to minus x plus 3. Now the magnitude of this is under root x square plus 1 is equal to minus x plus 3. Square both sides, you get x square plus 1 is equal to x square plus 9 minus 6x. This gets cancelled. You get 6x is equal to 9 minus 1 is 8. X is equal to, you get 4 by 3. So mod z becomes under root x square plus y square is equal to under root 16 by 9 plus 1, which is equal to under root 25 by 9, which is equal to 5 by 3. So the answer is B. B is the answer. Such a simple question. It hardly took 2 minutes. I think less than 2 minutes because I have taken little more longer steps. But if you have practiced it very well, then it will hardly take a minute or a minute and a half. That's all.